So, hi everybody, I am Patrick Thunstrom. I am a server developer at Dog on a Horse. I should probably be on my slides and not. Alright, you just saw my GitHub. If you want the code, it's PyGotham-Pygame under my GitHub account. I'll be walking through it all, so you don't need to download it right now if you want to play with it later. Pretty much I'm going to be walking through 3 example games, talking about what parts of the Pygame library I'm using for them. At the end of it, pretty much everything I show you, you should be able to make a decent game out of it. Not a whole lot of talk on how to actually do the game code. If that's what you were looking for, I'm sorry. All right, so the first thing I want to talk about is this. This is the bare line minimum code you need to make a black window that closes gracefully. Doesn't do anything else. I'm not even going to compile it. This is what it looks like. So pretty much, the thing is, there's a lot of magic going on in the background when you're using this. Starting with, right at the top, we've got pygame.init. A lot of the elements of the Pygame library actually have to be initialized, specifically display, font, trying to remember off the top of my head what other ones need it. But basically there's a bunch of elements that need to be initialized before you can use them. Pygame.init actually activates all of them at once. Truthfully, I don't like doing it anymore. Like when I actually design a game, I go through and only initialize modules I need. Which is something you can do. After the init, we've got the display, which is actually the reason we have a GUI in Pygame. The display is one of the modules that needs to be initialized. And in this case, what I'm doing is, with set mode, all I'm passing it is the size. It's a 300 by 300 pixel screen. That can be anything. If you don't put anything at all, the defaults for it will be your system resolution, so it'll start as full screen. It uses software rendering as the default. If you want hardware rendering, you have to actually pass a flag. The video driver is actually going to select what looks like the best driver for your system. Windows, it's the DirectX driver, and for most of the Linuxes, it defaults to X11. All right. After that, I've initialized the clock, which I realized after the fact, clock is not needed in this code, so I could actually cut a couple lines out. But clock is actually really useful. All it does is keep time. It also, if given when you actually call the tick method, you can actually sleep it so you can share the processor with other things. Next step, running equals true. This is actually just a thing I prefer with Pygame and pretty much any of my infinite loops. Instead of while true, just make it a variable that you can end the loop gracefully. Next step, pygame.event. The event library is probably the best part of the library because it is the easy way to get anything that happens on the system. Keyboard events, mouse events, joystick, Pygame.quit, which is actually has to do with the close button on your GUI, so the red X in Windows. In this case, I'm only handling the one event type, which is the quit event, and all I'm doing is stopping the loop when I do that. What you're seeing in that, though, the if event type. Every single event has a type, which is actually just an integer value. And in this case, it's equal to the Pygame local quit. There's actually an entire list of locals. It's very hard to get the whole list because unfortunately the documentation is not great. Basically, you've got the whole list of events, which is 1 to 23 are system events, 24 to 30... Do I have here? Of course I don't. All right, to 31, I believe, are user-created events, which I'll actually show you later how to do that. And then there's one that's just called num events, which is the limit of the event system. Then display.fill is actually, I'll talk about that one later actually, because pygame.display.setMode returns a surface, which you'll use a lot of, but I don't want to explain it here. And like I said, clock.tick, all that's doing is it's iterating the clock. If I had passed that a number, it would limit the frame rate to whatever number I gave it. So if I said clock.tick 60, it would only go 60 frames per second. It's that easy. And that's this example. Let's see. All right, so this is the second example, and it's pretty much all of the code for the second example. We'll be walking through it in a second. This game, I don't know, did anyone actually download and look at this one? Still all right, so short version, this one, you can't shoot anything. You can move back and forth, dodge the enemies, and they move. That's pretty much it. We're not even at sprites. I'm using primitives in this example. All right, so we start with our name equals main, which I hope everybody has seen this idiom before. Going over this one, OS environment variables. In this case, I'm accessing the SDL library variable, which is basically, this is another one. I actually had to go digging through the FAQs to find this one. The SDL library has a number of environment variables that it will respond to. Unfortunately, they're not well documented and subject to change. So use at your own risk. But in this case, SDL video centered actually works. All this is going to do is the window will open in the middle of the screen. Then I initialize Pygame, make a screen. In this case, it's going to be 300 by 600. Pygame.display.setCaption. This is actually the title bar of your window. In this case, I'm calling it pacifist because, well, I didn't take the time to put bullets into this game. And again, we do the game clock, and then I start the main loop with the game screen and the game clock. And then here's your main loop. What you saw last time, I'm handling a couple more key events. If you hit on this screen, like hitting quit, and then if you hit enter, you can start the game. In this case, I'm just calling game loop. If for some reason none of these events happen, it draws the title screen and then it ticks for 60 seconds. Title screen is where the interesting stuff starts happening. In this case, so draw title. We pass it the screen because we need that surface to be able to manipulate it. We fill it with black, so a surface is basically just an object that holds all of the pixels that we're going to be drawing. When you fill it, all it's doing is filling the whole thing with one color. It's really that easy. You use it a lot, basically. Anytime you need to reset the surface to draw your next frame, you've got to fill it with the old color, with the old background. Gonna skip spacing. It's used to, you'll see what it does in a minute. Screen width. Every surface has a handful of methods that let you get things like the width, the height, the color depth, things like that. In this case, I'm using that so that I can actually center all my text. Pygame.font.font. Font is another one that needs to be initialized. In this case, I did pygame.init because it was faster. In this case, I'm using the default Pygame font, which is why I've got a none there. If you put the name or file path of a font, it'll try to use that font instead. And then a size. And I'm using two different fonts here, just different sizes. Unfortunately, you cannot change font size in Pygame. You have to initialize a new font every time you want to change the size. Then a bunch of math to figure out where I'm putting this stuff. Then render is going to take your font, a message, if you want it anti-aliased or not, which is the true, and then the color that you want it rendered, and it returns a surface. So remember how I said we were going to use a lot of those? This is one of the other reasons. Then the next bit that you need to know is blitz. So with a surface, if you take a surface and you blit to it, you take another surface and apply it to the original surface. Does that make sense? In this case, I'm taking my new line of text, which is primitives in this case, not telling where to put it. which in this case, it says left and top, which is basically two integer values as a tuple, which is the top left corner of where to place the text. And then I do that all again, and then I do pygame.display.flip. Flip is actually the proper way to update the screen when you're using hardware rendering. What it does is it waits until the next time the screen would be updated, because it updates from top to bottom. Waits until the next time and then draws the new frame as it does the next pass. So that's what that one does. I was going to use update in the next example. It's not actually in here at this point. Update is the software render version. If you don't give it any parameters, it works just like flip. If you pass it a rectangle or a list of rectangles, it will actually only update those sections of the screen, but it is only something you can do with software rendering. So unfortunately, I don't have an example of that one in practice. And this is what all that code renders right here. It's not a whole lot. Unfortunately, fonts are hard to work with in Pygame. All right, so now we go to the game loop, which is quite a bit more text. In this case, I'm rendering a bunch of things for the game model, setting running to true, handling events, which again, we've got pygame.quit event, which is exactly like you've seen before, except I do one extra thing here. Event.post. With the event engine, you're actually allowed to put any number of events on there that you'd like. So if you want, you can actually simulate a mouse event by posting a mouse event. So all you do is post, pass it an event, which is pygame.event.event. In this case, I'm sending a quit event, so going into the locals, grabbing the quit number, and sending that along. Then we handle player controls, which in this case, key down and key up. When you hit the left or right key is how we're going to set the movement, which is actually, just quickly, it's the player vector is changed every time you do that. If you hit escape, it ends the game loop. And then if the player is hit by an enemy, we end the game loop. Actually, game over loop isn't actually implemented, so it's just, right now it's just passed. Then simulate, which I'll show in a moment. Draw the game, I'll show in a moment. 60 frames per second, like I said, and then we update the time using the return value from clock.tick, which in this case, it's an integer equaling the millisecond since the last time clock.tick was called. So that's how you know how much time has passed in the game. All right, so next one, the simulate. Pretty much this is basic math on letting the game do its thing. The important one is actually the rectangle value, which I just realized I did not walk through when I was explaining that. All right, pygame.rect. Rectangle is 4 numbers. Each one is going to, your first two are going to be the x coordinate and the y coordinate of the top left corner, then your width, and then your height. An important thing to remember with Pygame, and actually a lot of rendering things, your origin is not the bottom left, it's the top left. So 0, 0 is actually the top left corner. So that's how you define a rectangle. Then there's some interesting magic you can do with them. For example, all rectangles have a bunch of attributes that are things like the top side, or the bottom side, or the right side, left side, or in this case I'm using their x coordinate. And this is actually how we do the movement, is each frame, we're moving the center x value whatever direction the player vector goes. And that's it. That's how the player moves. These next couple of if statements are actually if the player's outside the window, it makes sure he stays in the window. And then we move the enemies. Then this right here, collide rect, is one of the values that you can do with a rectangle. There's all sorts of collides that rectangles can do. You can do collide point, collide rect. There's one that lets you do a list of rectangles and check if it collides with any of them. In this case, we only really care if the enemy hits the player, so we check if the enemy collides with the player's rectangle. If it does, we post a game over event, which is just event 25, which, as I said, is one of the user events. And then I spawn new enemies every half a second. And then the draw the game screen is actually a lot easier than drawing the title screen. We fill the screen, we draw the rectangles for the, we draw a rectangle for the player, and then for every enemy, we draw a rectangle for the enemy. All you're doing is using the Pygame.draw library, which has various things. You've got rect, polygon, circle, take your pick. There's a lot of different shapes. You pass it the screen to put it, the surface you're going to put it on, the color, and then a rectangle, and then the width of the outline. If you don't give this last variable, it just does a filled, which is actually dangerous with circles, I found out. I don't have an example of that, though. And then this is what it shows every... You actually cannot see the bad guys on that one. There's actually little red rectangles in here that are not showing up for whatever reason. That's the end of the slides, and we'll move on to the last example very quickly. This is actually a little more robust game. It actually uses sprites along with images. You can actually shoot in this one. Same basic setup. Center the video, set everything up. The title screen is the same name. The big difference is using sprites. So I'm going to show off sprites real quick. Pygame.sprite.sprite is the baseline class. It's got a handful of useful things. In general, there are two things it's going to need to make all of the other functions work. It needs a self.image and a self.rect. Everything else here is game code, so it's basically just there so that I can make the game do what I want it to do. In this case, my image is going to be, I'm going to use the image library to load a PNG file, then convert it. So when you get a surface and you convert it, you're actually matching the color depth, the alpha. Basically, you make two surfaces that they can blit very quickly. If you don't pass anything to convert, it uses the display surface. So that's what I'm doing, is I'm just making it so that that one can blit to the main game screen without a problem. Image.set color key. So when you set the color key on a surface, what you're doing is setting transparency. In this case, it's a bright pink color. The rectangle, I'm using surface.getRect, which, similar to the ones like getWidth or getHeight, all I'm actually asking for is the actual, for a rectangle object that matches the surface. I do this for all of my sprites. Let's see. Is there anything else in there that I need to show? Yeah, unfortunately, I didn't get to the slides for this one. So. Nope, that's the same. Bullets I did a little differently. I actually created just a surface and then drew a rectangle onto it and used that as the sprite. So it's just a little 2x2 white rectangle. So you don't need to use image files if you don't want to for sprites. You just have to make sure they have their own surface to work with. And then, all right, so all of them have an update function, which is useful for the other thing I'm going to show. And then they all have a built-in draw function that they inherit from Sprite. It just takes their surface and draws it wherever their rectangle is on the main screen. All right, and then game loop. All right, so this is the interesting part. This game loop looks quite a bit simpler than the last one. So I'm using two different kinds of groups. I'm using sprite.groupSingle, which basically holds one sprite at a time. And then using two groups, one for enemies, one for bullets. The important thing about groups is they have a couple of functions that let you do some interesting things. But primarily, it's their update and their draw events that you want. Because what they let you do is walk through every sprite in the group and update them via whatever your update code is, and then draw them to the screen. And then while running, handle game events, tick the clock, update all of those elements that I just showed you, fill the screen, draw everything, and flip the screen. This is how clean your main event loops can get once you know what you're doing. Game events, pretty much everything you saw before. In this case, though, I have actually defined a player shot, an enemy shot, game over. Yeah, those are the only three I finished. And pretty much it's just so that I can create the bullets when something fires. And game over is basically the same as a quit event. It just is cleaner for the code. Let's see. And I believe that is everything in this example. All right, so any questions? I know I kind of had to rush through that last one. Can you play it? Yes, actually. I didn't play it long, but... Oh, hey, what do you know? It's even the last one I loaded. All right, here we go. Don't know if we'll be able to see the enemies, though. Oh, that's right. They're... And I died. It's very hard to play backwards. I'm sorry. So yeah, no, it runs. While it's running, I showed you the that posting the quit event. What it does is it actually closes all the way from wherever you're at. It's mostly me tricking the game state because I'm running it as loops and loops instead of using break statements. I handle a quit event, which will end one of my loops, post a new quit event so the loop outside of it can handle it, and it'll just chain its way up to the loop and quit. So that was just a trick I actually figured out this week. It was kind of cool.
I played with PyGotham before.
Okay.
And they have like some limited like keyboard controls and that are pretty not cool. Like they're not great.
Okay.
I'm not going to destroy them if they work, but it's kind of like when you push the button, you have to wait for your keyboard's repeat function to happen for like it to keep doing stuff. The controls on this are you're saying are sweet? They're like well like or a little weird.
There's
what have you found with the controls like using the keyboard?
You have to know a couple of tricks with it. For example, if you set a variable when you key down, if you don't reverse it when you key up, that variable will stay set. So you do have to know about a few little tricks like that. But in general, because it's the actual event of the key down, the key up, or there's actually one thing you can do with the keyboard, which is you can get the current state of every key on the keyboard, which is either on or off. I generally don't use that because when you're talking real time, you kind of want everything to respond when the player hits, which is why I use the event system. I want every key press to be used. Whereas if your loop is running slow and you check the state of the keyboard, it's only going to give you what happened when you actually asked for that check. So that's...
Do you do multiple keys?
Yeah. In fact, I didn't show with this one, but if I hit left and right when I'm doing this... Sorry, center is my main monitor here. If I hit left and right, it doesn't do anything. It's reading both and trying to move on both. So. Yep.
Why do you, when you press the, so I'm looking at the code, so, when you press the key down, you like, if it's to the right, you add to the vector 3, but
yep.
You subtract it again if you, once the key up comes down?
Yeah, because I need to reset it to 0.
Okay.
What I'm doing is when I hit key down, I want them to be moving right, and then when it comes up, it has to come back. All right? Anything else? No? Okay, then I think that's it.
Thank you.
All right. Like I said, if you want any of the code, it's on my GitHub. PA Thunstrom. There's also other Python games in various states of disarray. Including one that I was actually doing MVC, which really does not work with Pygame very well.
Patrick, thank you so much. It's fantastic.
All right. Let me.
Yeah, we will have 5 minutes before we start our next go. Awesome. Finding your stack.
Nope, don't want to save that.
Great job.
Yeah, thanks.
7:05.